In this video, we'll do an example where we have to find an infinite limit that involves the square root of some complicated stuff inside. So the example says to find the horizontal asymptotes of this function g of x. So recall, if I want to find the horizontal asymptotes, we need to find two limits. The limit as x goes to positive infinity of g of x, and we have to find the limit as x goes to negative infinity of g of x, because a horizontal asymptote could appear in either the positive infinity direction or the negative infinity direction, or both. It could have a graph that has an asymptote this way and then another asymptote as I go this way. So I got to take the limit as you go to infinity and negative infinity. All right, and okay, so let's begin with a limit as x goes to infinity. The limit as x goes to infinity of the square root of 9x to the 6th plus x squared plus 1 over 2x cubed minus x. So let's use our strategy from before, where we will try to factor out the highest power of x that we see on the top and on the bottom. And on the top, that's this x to the 6th inside of the square root. We'll get the limit as x approaches infinity. Let's factor out that x to the 6th. This is all going to be in the square root. That'll leave me with a 9, and then plus, we'll get x squared divided by x to the 6th, which is 1 over x to the 4. And then the last term divided by x to the 6th, 1 over x to the 6th. And then on the bottom, the biggest power of x is this x cubed. Factoring that out leaves us with 2, and then minus x divided by x cubed, which is 1 over x squared. All right, so next let's use a square root property. We get the limit as x approaches infinity. We can split up the square root to be the square root of the first term, the x to the 6th, and then times the square root of everything else, that 9 plus 1x to the 4 plus 1 over x to the 4 plus 1 over x to the 6th. So when I'm multiplying two things in a square root, I can split it up like that. And on the bottom we have, let's keep it as x cubed times 2 minus 1 over x to the 3rd. All right, so I want to simplify the square root of x to the 6th. And okay, so let's write that on the side. Square root of x to the 6th, I want to simplify. It might be really tempting to say, wait, isn't this just x cubed? But going back to our video from last time, remember we said that the square root of x squared was equal to the absolute value of x. Because even when you plugged in negative numbers in for the x, like this -3, squaring it ended up making that non-negative. And then even when you square root of that, it stayed non-negative. So the absolute value was going to guarantee that the output was non-negative. And in our example, similarly with square root of x to the 6th, we are going to need to put an absolute value around x cubed because x to the 6th is non-negative no matter what type of thing you plug into it, positive or number or negative number or 0. It's going to be non-negative. So the square root of x to the 6th must be non-negative. And because of that, we need to make sure we put an absolute value around the x cubed. If I didn't have an absolute value around the x cubed, then the x cubed could be negative sometimes, but the left-hand side, the square root of x to the 6th, cannot be negative, and that would be bad. They have to always have the same sign. Okay, so this gives us the limit as x approaches infinity. All right, and the square root of x to the 6th is going to be the absolute value of x cubed. Well, let's simplify an absolute value. I know if I have the absolute value of some stuff, I can write this as a piecewise function. It's going to be equal to just the stuff inside if that stuff is non-negative. And that happens if x is greater than or equal to 0. If, on the other hand, x is less than 0, then the x to the 3rd is negative. So I can't just write x to the 3rd, because the absolute value is supposed to change the sign. I would need to put another negative in front of that to guarantee that this is now non-negative. All right, so the situation I'm in, if x is approaching infinity, is that x is greater than 0. And if x is greater than 0, then the absolute value of x cubed just becomes x cubed. The x cubed is already positive, so I don't need the absolute value around it. Okay, so here this just becomes x cubed times the square root of 9 plus 1 over x to the 4th plus 1 over x to the 6th over x to the 3rd times 2 minus 1 over x to the 3rd. Now we can cancel the x cubes and we can plug in. So I'll get 9 plus 1 over infinity, which is getting close to 0, and then plus another 1 over infinity, which is getting close to 0, over 2 minus 1 over infinity, which is getting close to 0. All right, this simplifies to square root of 9 is 3, and then over 2. All right, so that is my limit as x approaches infinity of this function. All right, now let's do the limit as we approach negative infinity. And I'm going to put a little bubble around all of this other reasoning that we wrote. Okay, now let's do our other limit. The limit as x approaches negative infinity of this function. Square root of 9x to the 6th plus x squared plus 1 over 2x cubed minus that x. Okay, so we're going to factor the highest powers like before. We'll get the limit as x approaches negative infinity. I'm just going to jump to the step where I could say that I'll get the square root of x to the 6th. I'm going to factor out the x to the 6th times the square root of 9 plus 1 over x to the 4 plus 1 over x to the 6th. And on the bottom, if I factor out x cubed, I'm left with 2 minus 1 over x squared. In this case, though, we get the limit as x approaches negative infinity. And for this square root term, square root of x to the 6th, that's going to be the absolute value of x cubed. But because x is going to negative infinity, this means x is less than 0. It's negative. And in that case, that square root of x to the 6th will simplify to negative x to the 3rd. Okay, so I got to write negative x to the 3rd there, times that square root of 9 plus 1 over x to the 4th plus 1 over x to the 6th over x cubed times 2 minus 1 over x squared. I can cancel the x cubes, but this time I still have this negative in front. So if I plug in now, I'll get negative root 9, and then plugging in negative infinity to these denominators, each of those fractions gets really close to 0. So plus 0, plus 0. And then all over on the bottom, I'll get 2 minus, this fraction also gets close to 0. So simplifying, this is negative 3 over 2. All right, so my limit as x approaches infinity of my function was positive 3/2. As x approached negative infinity, it was negative 3/2. So I know my horizontal asymptotes. My horizontal asymptotes, I'm just going to abbreviate. One of them, let's write it as an equation of a line, is y equals positive 3/2. And the other one is y equals negative 3/2. I have to write y equals the number to get a horizontal line. All right, those are my answers. In terms of our goals, we've now done a problem where we found the horizontal asymptotes of a function. This also touches on the fourth goal, which is evaluating infinite limits that involve the square root of some complicated stuff. But we'll do another example of that in the next video.